Okay, guys, it's just gone 3 o'clock on my watch, so I don't want to waste any time. So I want to make sure we get through it. There's quite a bit to cover. Just to let you guys know, this webinar will be recorded, and that recording will be made available to everybody that's registered. Could I just ask that everybody mute their microphones during the presentation, and also if you could just turn off your videos as well, just to save a bit of bandwidth. And if you've got any questions during the presentation, just please add them to the chat box, and we're going to have a QA session at the end, and we'll go through all of them. So today's topic we're going to be chatting about is going to be around scan to BIM, and if that decision to sort of invest in a 3D scanner is causing a bit of confusion and giving you a headache, hopefully we'll try and clarify that a few things for you today, and sort of give you confidence that this is not only a sort of a viable option, but it's also tried and tested. I'm joined here by Magnus from, he's the Managing Director of ParaMatic, and he's going to be discussing how they're using 3D scanning in their advanced 3D constructible models that they build, and also in their Brownfields engineering solutions. So it's going to be really interesting. So let's get going. So just as a agenda, I'm just going to do a quick introduction. We're going to go over some scan to BIM. We're going to look at something called BIM to scan. I'll just remember if that catchphrase ever takes off, you heard it here first. And we'll look at some practical examples of the above. And then I'm going to hand over to Marinus to tell us a bit about ParaMatic projects. So just to start at the top with the Optron Group. So the Optron Group has been a Trimble geospatial partner supplying positioning technologies throughout Africa for 30 years now. And although known best probably for their geospatial and their survey sector, Optron also has SciTech, so as their heavy civils, Vantage, so their agricultural division. And our division is called Building Point, and we represent the Trimble vertical buildings portfolio. And we support and provide solutions to everybody that's operating in that in the architecture, engineering, and construction space. Our scanning, layout, and mixed reality hardware is specifically designed for efficient AEC workflows. Just about the OnPoint webinar series, just to give you an idea of what we're trying to achieve with it. We've got a whole lot of, within Building Point, a lot of these solutions like Tekla, SketchUp, there's construction verification software, point cloud processing software, common data environments. And then we've got field technologies for layout, for 3D scanning, for augmented and mixed reality. And instead of just showing each product in isolation, we want to showcase these as part of an AEC solution, because this is how you're going to use them. We're showing how they integrate with your existing infrastructure, how they interface with each other, and how they use together to optimize workflows. Okay, then we get started on our main topic, which is scan to BIM. We're just going to if we take a look at the types of scanners that you're going to be exposed to nowadays. We've got static scanners. That's one of the most common. The one you're going to see, that's the one that sits on top of a tripod. We've got SLAM scanners. These are usually handheld scanners that you can walk around, quite mobile, capture data, and it maps your environment on the fly. We also get mobile scanners. Scanners can mount on vehicles, and now becoming quite popular also LiDAR scanners, specifically becoming popular when they're mounted onto drones. But for most scanning applications, especially for scan to BIM, what you're going to need from your scanner is a good level of accuracy. It's got to have reliable repeatability in most types of environments, and also portability as well to get in both sort of inside and outside. So for this reason and the purpose of this presentation, I'm only going to be focusing on static scanning, the static scanner. And when considering what scan is appropriate for your scan to BIM application, there's three things that I would recommend you should consider. One of them being the scan speed and density, but that also versus the data size and processing. So a raw scan file, depending on your brand of scanner and the capability of the scanner, can range anything between 40 megabytes to 2.5 gigabytes for one scan. So I found from experience sort of the sweet spot to be somewhere around the 100 to 150 megabytes per scan size. This usually equates to a scan density of around 15 millimeters at 30 meters, which you're still going to be filtering data at that sort of density. I mean, you want the data to be able to run on an average to good laptop. If it can only run on the one Office supercomputer, then you've created yourself a bottleneck. If you need to purchase every user in the office a 150,000 Rand supercomputer, then you've got yourself an efficiency issue. So on the topic of efficiency, most scanners now also come with, they're usually operated from tablets nowadays. That's sort of your interface with the scanner, because there's lots of functionality, additional functionality that you can do in the field. So have a look at what is that functionality and how can it benefit you, how much can actually be done on the fly. And then look at scan quality for effective feature extraction. So for example, in these two videos we're looking at, this is a great example where ceiling voids, they're an awkward task to tackle. So usually very messy, very confined, difficult to access, full of objects made from highly reflective materials such as ducting and that shiny insulation that you get around the air conditioning pipes, as well as on the other end of the scale, very matte sort of HDPE pipes. And these are all things that were historically quite difficult to scan. So make sure you've got the scanners that have got these high sensitivity settings so that they're able to capture all that information. So, I mean, you'll see from the two examples, the one on the left, the scanner was sort of chosen for its portability, but clearly to be able to see anything that's in that data and extract anything would be very difficult. Whereas the one on the right, you can see is high quality. You can see the detail of all the hangers, all the stringers, even all the, even down to the cables and stuff, all very clear inside that data set. So my preferred scanner of choice for scan to BIM applications is the Trimble X7. The scan is focused on improving field productivity for the whole AEC industry when controlled with the Trimble fielding software. Some of the technology breakthroughs in it are things like Infield registration, that's full registration, and refinement, not just sort of a pre-register. Automatic calibration, so every time you start up your scanner, it'll run a calibration routine so you can have 100% confidence that you're in your data. And you can even produce a valid calibration certificate directly from the scanner within about 2 to 3 minutes whenever you want. It has basic set-out capability, automatic level detection, it's got a survey-grade compensator, integrated laser pointer. This is great for helping you align your data with 3D models, DWGs, or even PDFs. So not necessarily always needing a total station to measure in coordinates of targets. And also the laser pointer is great for the setting out functionality as well. And then direct export. I mean, if you can do all the registration and refinement on the scanner, it would be great to export it to industry formats such as a RCP file, both structured or unstructured. The same for E57, so structured, unstructured E57s for if you're using Tekla or ArchiCAD or POD for Bentley. And then there's the design to point cloud analytics. That's another feature that's introduced onto the X7. I think one of the factors that sort of contributes to an apprehension towards people getting into scan to BIM is that word BIM. We hear these terms, BIM, digital twins, digital transformation, smart cities, and they all sound like pretty advanced stuff, and they can be quite daunting to take that first step and to actually get involved. But the word BIM means different things to different people depending on your profession. So an architect's focus on BIM will be totally different from a project manager's focus. Same as, it'll totally be different from a contractor. But everyone contributes their own bit to the process, and in theory, we all work in a better way for it. This doesn't mean that you have to know everything about everybody else's contribution to the process. Just focus on your bit and doing that bit well. So this could mean that if you're only interested in your focus is doing scan to BIM, then your area of expertise could be, I'll probably get a bit of kickback from this from some people, but it could just be producing 3D models in itself. That in itself is a valuable contribution to the BIM process. And if you're used to drafting in 2D, you may also be apprehensive of it. But you don't actually have to draw every single line in 3D. My experience is nothing like drafting. It's much easier. If I do try and relate it to something else, I would say it's more similar to building Lego. So your 3D scan data being your instruction manual, giving you all the detail from every angle, showing you what pieces need to be put where. So yeah, my advice, just give it a go. And if you get stuck, give me a call. We're always happy to help and share. Another misconception about, I think, one of these hurdles to overcome, the daunting things, is that scan to BIM is something that only gets used on big projects like oil and gas and industrial facilities and stuff like that. And while that's correct and that it definitely has its place there and it does a fantastic job, and Marinus will be showing us a lot of that later. And you can see from this video as well, this is one that's kindly supplied by Ian Thompson from Cape Survey. He let us use this sort of data set, and you can see it just gives you an indication of sort of the level of detail, what you're able to produce from point clouds when you tasked with sort of doing a survey of a sort of an industrial, in this case, an industrial warehouse. And when doing these larger projects, we've also got tools that can aid you in sort of tackling these larger projects like EDGEWISE. So this really comes into play when you're needing to extract things like steel frames and steel structures. The software will automatically fit steel sections from a catalog. And we've created a catalog for the South African Red Book, so all the hot rolled steel is already loaded into EDGEWISE, so you're able to fit members from our Red Book sort of section sizes. And EDGEWISE does the same for piping and ducting. So in plant environments and inside ceilings, we tend to find lots of ducts and plants. This can help improve your modeling turnaround times. Yeah. And as I mentioned earlier, the scan to BIM is scalable. It doesn't always have to be the large project. And I think because Marinus he operates in that space of these big projects, big brownfield sites, big engineering sites. I thought I'd show you on the opposite end of the spectrum. This is just a scan of a residential house, scanned with an X7 scanner. It was 30 scans to do it, 1 minute to scan plus 1 minute to do color, registered on the fly, refined on a tablet, found and exported to an RCP file, and then directly from the scanner into Revit to be modeled. And the scanning time was under 2 hours. The time that it was spent to model it, the professionals will laugh at me, but it took me about 6 hours to do that. But I don't do it every day, so it's it actually took longer to render this little video than it did to draw the model. And if we look at the deliverable from scan to BIM, the 3D model doesn't necessarily always have to be what's specified. I mean, even the fact that once we've got a 3D model, within minutes you can produce any amount of detail in 2D drawings and sections and elevations. That's where the efficiency really happens. So even if the specification of the project is a site plan, maybe 2 sections and a couple of elevations on a project like this size, it would have been quicker to produce that 3D model first than to do that each of those sections individually. There's just an example. That's just what the sections and elevations that you can produce, and it's really, really quick, literally a couple of minutes. But it doesn't end there. So now we've got this great looking model, but how do we know how good is it? How accurate is that model? Can that model be trusted? So in this example, we've got the model, it's been done in Revit. I want to check the accuracy of the scanning that was done downstairs. So because everything, it's a BIM model, I can turn off the classification. I turned off there all the furniture. So I took out all the furniture, I just clipped it down to the bottom floor. And then I sent that model directly from Revit. I said send to Trimble Connect. Now Trimble Connect is Trimble's cloud-based sort of common data environment. And that little clip of that data is sent to, this is a view of Trimble Connect online. You can see that model. I didn't have to clip it. The only reason I've clipped it is just to show you that I can. You don't always have to upload the full scan file. Now this is the interface on board your scanner. So your scanner can also link to Trimble Connect. So the scanner goes onto Trimble Connect, imports that model that was just exported from Revit. That could be in completely different locations. And now I've got that 3D, the as-built model loaded onto my scanner. Now, as you can see, this is quite a really nice interface to be just manipulating your data on board the scanner. You can use these clipping boxes just to isolate your area of interest. And when we clip down to the bottom, you'll be able to see there's the point cloud and the model all sort of overlaid one on top of the other. Now you can also do an inspection. So on board my scanner, I can even do an inspection. I can compare the difference to see how accurate that model was modeled. In this case, I'm setting a tolerance of 100 millimeters and going to colorize the point cloud into 20 millimeter tolerance intervals. So from green up to red in 20 millimeter intervals. And it'll then colorize the point cloud accordingly, so I can see where the deviations are. Once I hit that that compute button, it will start to process it. Yes, I sped that up a bit, but it didn't take long, about 2 minutes less to just do that inspection. And there you can now see the point cloud and the model. I can change the transparency of my model just so that I can get a better view of my point cloud. I can turn the model off if I like. And now I can see where the modeling is good and where it's bad. Where it's green, it's within 20 millimeters. There's some couple of blue walls. That's between blues. You can see the scale on the side. That's sort of 20 to 60 millimeters. So I would probably go back and I would edit those walls back in Revit. But what's nice is you can take that. You can have the confidence that what you're producing, you can check it and you can make when you deliver it, you can be sure that there's going to be no comebacks. So what we did there is what I called sort of BIM to scan, construction verification. We took our BIM model and we brought it back onto our scan data. So if we can take BIM models and take 3D models and put them on our scanners, what else can you do with it other than now just collecting and sending your scan data to the office? So other applications could be like, for example, here are some examples that we've used it for facade alignment, to check that your facade is going to fit, that your that your slab edges line up properly. And that, in this case, this was only 6 scans at 2 minutes a scan. So within 20 minutes, we can confirm whether there's going to be any issues when it comes to installing the facades. Things like checking the verticality of lift shafts. A couple of scans inside a lift shaft right there and then in the field, and you can see if there's going to be any issues. Checking cover for rebar, checking your formwork before you cast. Floor flatness inspections. This is quite a cool application in that you can even, if you scan a concrete floor, even while the concrete is wet, You can identify where the high and the low spots are. And in the scanner with its laser pointer, you can tell it, it'll point out where the high and the low spots are while the concrete is still wet. So you can really sort of avoid issues before they happen. So like I said, we've got these technologies, and I want to try show you, let's show it as a solution, as Infield in practice, as an AEC solution. So I've showed you just a random model that we did for the example of this presentation, but let me show you it in practice. So here we wanted to check as-built conditions. This is a site. There were 70-odd scans done at a minute and a half per scan, or auto-registering itself on site. We were on site for about 3 hours to complete that floor, that scan. And then what we do is we're able to do this in-field inspection. So I've got this is now the interface again that you're looking at from on the scanner that you'll have in the field. I've got a 3D model of my columns loaded, set my inspection tolerances, and straight away I can identify. I don't have to do a scan, send it back to the office, and then manually go through and try and find out where there are any deviations. I can see it right there in the field, and the relevant people can be made aware of it. And what's nice is you can also have 2D information there as well, so you can bring in PDFs. You can get a lot of information and context from overlaying your 3D with the 2D. So I'm looking at a column, but the reference, the column number, that type of thing is just very quick and easy to see when you overlay a 2D PDF alongside your 3D model and your inspection. Now, I can take that point cloud and I can export it. Yeah, I'm exporting it to RCP file, recap file, Autodesk file, and then bringing it. This is into Civil 3D. Now, as much as I'm an evangelist for 3D, I'm also a realist and understand that there's always going to be a need for somebody's going to need a 2D PDF at the end of the day to put in a file in the office, punch it, and file it away. Probably not to be looked at again, but it's a requirement and needs to be done. But now we know where to look. We know where the issues are, so you can very quickly just go and draft and create those drawings. Now, if you look at this comment, this is quite an interesting note on that, and it says, check the columns below before, the starter bars below before casting these columns. And this is where you really see a lot of value in having this, taking your BIM model out to site. So if it's used, for example, in the case of sort of QA, QC, here you can see you've got a column, and it's very clear that the starter bars are sitting on the outside of that column. And this is picked up obviously before it is cast, before it becomes a problem. And if you, I mean, in this specific instance, you just need to look at, you can see where the columns are situated. They're next to a staircase. It could be a fire escape. In that case, it's probably going to affect things like the handrail. So you're going to have to get not only the structural engineer to check if the columns are still going to be okay, possibly the architect needs to get involved because of the handrails, fire engineer for compliance. And the cost of a mistake like this is far more than just the cost of the concrete that goes into the column that needs to be broken back out again. So being able to pick these things up before they happen and be able to fix it at this stage, there's a huge amount of value in being able to bring your models onto your scanner and be able to do this type of checking and analysis and alignment in the field. So I'm going to, that's the end of listening to me. We're going to do a very quick swap. Hand over to yes.
If I can just ask you, seeing as your session has come to a close, there is one question in the chat. I don't know if you might want to just tackle that now.
Yeah, let's go for it. me see, Terry. How stringent the deviation check can go with Trimble equipment, 2 millimeters plus? Yeah, so you kind of, depends on the scanner is, you're looking at 2 millimeters. So yes, I'm not too sure if you might be asking that. Probably 2 millimeters. People always ask, or how accurate can you check? Probably because of, especially with flooring, things like warehouse flooring, like the FM TR34 classifications and stuff like that. We can probably, I'd say, do up to a FM2 type thing. But yeah, about I wouldn't. 2 millimeters is the accuracy of the scanner. Whatever that deviation is, if it is 2 millimeters, you'll be able to see it. I wouldn't. I've got to be realistic. I wouldn't say you're not going to get see less than that.
Also depends on how far that scan was. So
Yeah.
if you're scanning further away, then it won't be nearly as accurate.
Yeah, you've got to. There's lots of factors which, your range, or. But if you have a specific example you're thinking of, Terry, yeah, let me know. It would be great to. I'm always open to try it. So let's go. We can go on site and we can test it. Yeah, always happy to give it a go. Robert, how much would it cost to carry out a laser scan? So one thing about Building Point, which we're different probably I think to every other supplier of scanners in South Africa, we don't do the scanning ourselves. We do not compete with our customers. We sell the scanners to our customers. So yeah, I won't be able to give you a price on how much it costs to carry out a laser scan.
Only.
But Marinus, definitely we can put you in contact with. We're actually going to be putting a list of all our customer supply, guys that are capable of doing scanning, and they can actually put what their speciality is in scanning, and we might, we can have that list of people to contact on our website as well. Okay, so we'll come back to the questions at the end. So maybe we hand over to Marinus and we can take us through some of the exciting stuff that he does.
Okay, so hi everyone. My name is Marinus, not Marinus.
You could have told me that earlier.
I'm the managing director of ParaMatic. We started in 2018, and we specialize in quite a few industries, but mainly in the automation of engineering, as our slogan says. I'm going to take you through the introduction and then show you some of the engineering and detailing of multiple disciplines within Brownfields. Our piping add-on for Tekla structures that we've developed and selling internationally, and then delivering a constructible and a true constructible LOD 400 BIM model, and then some further automated engineering solutions that we can discuss later on. Myself and my team have an extensive experience with most CAD engineering packages, and we've come to the conclusion that the perfect CAD package for plant engineering does not exist, especially when it comes to delivering detailed drawings and fabrication details as a deliverable. Most CAD software salesmen are always trying to sell an additional system or piece of software, whereas we're trying to sell you a solution. We develop most of our software, or all of our software in-house, using mostly C#, but sometimes C++, SQL, PowerShell, Python, HTML, and VBA. We're selling a lot of software internationally. This is mainly in the engineering fields, all the way up from automated conveyors, where a conveyor would take a general company about 160 hours to design and detail. It takes us about 1 minute and 38 seconds to do the same. Well, I'm not here to sell Tekla. I'm not a Tekla reseller. Brent and his team is. So if you ever want to buy a Tekla and you feel that this demonstration fits in with your goals, maybe give them a call. We're more here to offer drawing offer support and assistance to ensure efficiency, competent designs and details. And then we use our own software in-house, so we split up between two companies, one being a software development company and the other being a standalone drawing office where we can assist you with any of your necessary developments, deliverables. We're going to play this little video. So these are some of the work that we've done in Brownfields using actually an X7 that Brent has shown us earlier. So the fly-through that you see over here is done within the 3D scan. So instead of having to generate a 3D model from the 3D scan, we interface directly with it, accurate to, as we just discussed, to about 2 millimeters. So we're able to then tie in with the existing infrastructure. And our aim is generally to eliminate unnecessary site work and brownfields, such as welding, bending of rebar, site running of piping, and so forth. And we do this by detailing bolted connections, leaving the site crew to drill holes positioned by our 3D model. So this means that they're not required to do any site welding, fixing of paint, and that sort of thing. It also makes it a lot easier by fabricating all of the big stuff off-site. We also provide detailed bending schedules that can be bent off-site and then placed within the already civil worked ground fields. And then we also deliver the detailed fabrication drawings of all piping that ensures and this ensures that the piping spools are accurately fabricated off-site and then ties in within the 3D scan to ensure that it's going to fit on site. These are some examples of work that we've done, as I mentioned before. This was quite an interesting one where we scanned one of these big excavators and we were tasked to detail all of the hydraulic piping for replacement. The piping was fabricated off-site and installed and bolted in place on site. And then some other work, including walkways, piping, pipe supports, a lot of rerouting of existing pipes because of general issues on site. And then, as you can see, there's some structural steel work detailed into the actual BIM Brownfields 3D scan model. We also specialize in the cable racking and that sort of thing if you needed to reroute some cable racking. Other than that, we also, as I mentioned before, have developed some software. This is our piping solution for Tekla structures. I'm not sure if everyone is familiar with Tekla structures. I'm sure not, but this is a very simple demo of what we can do with Tekla. The piping suite is sold completely separate from Tekla itself, so you would require a Tekla seat or Tekla license. But once you obtain that, you can buy the software from us directly. The software allows you to add all kinds of fittings, elbows, T-pieces, reducers, flanges, and so forth. As you can see, it's all driven by the pipe size, so depending on what pipe you used, the fitting will look for the specific sizes from an online database. The database is driven by ParaMatic, so if you require a new standard of fitting to be added, we will add that on your behalf. This means our database is continuously growing with all the standards, eliminating the requirement from you as a customer to develop these libraries yourself. There's very easy to use user interfaces that allows you to change the fittings and add additional flanges, change the flange settings, welds, and so forth. As you can see, it's very easy. You're also able to use the structural steel, and that's one of the plus points of using our system. Is it's actually the only piping detailing solution where you can detail both piping and structural steel within the same platform. All other platforms allows you to run piping, lay it out, but you aren't really able to detail it to the level of fabrication that you can do so in Tekla structures. So you can see the flange there is then assigned to the tip of that I-beam, so it will never extend past that specific column over there. the drawings generated from the system and the reports, and it should be done right now in this video. Just give it a second. First the reducer. Maybe just go through it for a second there. The reducers are also database driven. Everything in this platform is database driven. So there's no need to parametrically model anything on your end to create a new library. And as I said, you can adjust the output with a few user interfaces and user boxes.
It's an incredible level of detail.
Yeah, so you'll see it includes all the bolts to the last bolt and weld. So the welds are even calculated. We can export a weld length report to tell you exactly how much welding you expected to build that specific piece of pipe. From here, we can then generate reports and the drawings, and they're done instantaneously, as if you know Tekla structures, you'd know how easy it is to create drawings. If not, well, you'll be witnessing it right now. These are reports that's generated. So that's a bolt assembly list, a bolts list, a bolt list per spool, buyout list per spool. Then just a standard buyout list, so that you'll send to your supplier. A line breakdown list to build that specific pipeline that you saw us model over there. And then the pipe material list, that's also to just go to your pipe supplier. So these things are all used then to quite easily quantify whatever you require to build that specific pipe. From there, we can then go over to the drawings that's generated automatically. It generates a rough overview of the line and then some spool drawings dimensioned accurately to be fabricated. Instead of trying to use isometric drawings, which I don't believe most of our artisans can read anymore, we give you a detailed fabrication drawing. Now, the rest of this demo is a little bit more about Tekla structures. So you can see it's very easy to model and generate a constructible BIM model using the user interface. You can move the beams and columns around. There's no need for driving sketches or anything to move anything around. You can add the connections, and these are generally pre-configured connections, especially to our standards, our South African standard connections. To adapt the structural steel is very easy. It's done in the 3D space, so it's not always necessary to cut a few views or look at the structure from a plan perspective. You can just add it by looking at the 3D view itself.
Those connection details are busy being done.
Yeah.
As you're drawing them up as well.
Yeah, they are. Yeah. So there you can see some pipe support, and because we've done the piping and the structural steel within the same platform, we're now able to tie the two together. So this means that the pipe support is live and connected to both the pipe and the actual structural steel. So if I decide to make a change to the structural steel, you'll see the pipe support will update automatically. This means that there's no rework required between two interfaces or two different platforms. And then if you move the pipe up by, say, 500 millimeters, you'll see the pipe supports and everything will adapt together with the actual pipe itself. And then the structural drawings are generated using the Tekla structural engine or the drawing engine. You have to just apply some numbering. Tekla does the numbering itself, so you just give it a prefix and it will compare the parts to ensure that there aren't any duplicates. And then the drawings are generated from some pre-set up templates, as you can see over there, column, and then the little pipe support itself. Other than that, because we've done the work in Tekla structures, and that being a constructible BIM model or constructible BIM platform, we're able to then deliver a 3D BIM model to the level of, or LOD 400 BIM model. And what that really means is that you can obtain, and anyone within the project can obtain, all the information required to fabricate and construct and maintain this plant. So if you look at the information embedded in each one of these objects, it's very simple then to understand what kind of elbow that is. So you can scroll down, you can see what the line number is, what the pin ID it is that's tied to it, and also that assembly number. Now that assembly number is generally the spool number for that piece of spool piece, or that spool piece of the pipe. That's added to the spool piece when fabricated. So when that piece of pipe arrives on site, you can simply search for that spool number and then know exactly where to place it within your site. So no more need for 2D GA drawings and walk around with the A1 trying to figure out where that specific pipe goes. The same goes for bolts and every other piece of detail on this model, or every other element. You can distinguish what size bolts you required to bolt those two assemblies to each other. And this is all obtainable from the Trimble Connect model. Trimble Connect is viewable from any device, so a laptop, cell phone, tablet, and it's all linked to the online cloud system. So as soon as we make a change on our end in the offices in Johannesburg, you can be on site and you will immediately have that change reflect on your end. So very powerful stuff in my opinion. This specific plant was put up without any 2D GA drawings. They were able to erect the entire plant by just using the tablet on site in Tanzania in the middle of Africa. And that's it from me on there. This my next slide is just thank you for watching. And then if you guys need any assistance with detailing or modeling or even if it's 3D scanning, you're more than welcome to give us a call.
Thanks very much. Thanks for honest. You never feel stupid. That's pretty impressive, the stuff that you do. And you know, one of the comments that he made when he started, there was I can't remember what you said. It takes people 2 days to do something you're able to do in 1.5 minutes and stuff like that. It's not. He's not lying. I've seen it in action when you do those sort of conveyors, and literally from within minutes he's designed a conveyor system with every single nut and bolt, and very impressive, the amount of customization and detailing and stuff that ParaMatic are able to do. So yeah,
thanks, Brent.
Please do make contact with them. This is down in your line of work. So yeah, if there are any questions that any of the people watching have got for either myself or for Marinus.
That's better.
I'm from Durban. Please, if you want to have a question, please feel free. You can unmute your mic as well, or type the question in the chat box.
Hi, do you hear me?
Yeah, we can hear you.
Yeah, well, I'm Thierry from Folgers in Mauritius. I'm not in South Africa. My company has to relocate a whole sugar factory which has been decommissioned to Tanzania.
Yeah.
Would you advise to 3D scan the equipment, the steel structure support, to do the new layout implementation? Because otherwise we'll have to take dimensions by hand and do the layout, do the 3D model using any CAD software.
So we've actually successfully done that in one of our projects where we scanned the existing model, or the existing site. Then we created a BIM 3D model in Tekla for that specific plant and assigned a serial number to each member or each piece of each object within the plant. And then when relocating it to the new plant, we were able to give a full erection sequence and instruction to then reconstruct that plant in the new location.
But what about the tolerance of relocating the equipment? Because sometimes the equipment are interconnected. So tolerance is something that you have to watch for.
Yes, I mean the scan, as we mentioned before, tolerance-wise is accurate to about 2 millimeters, and a plant like that with a plant like that shouldn't be a problem.
Okay, and how long did you take to scan everything and rework the layout, the new layout?
I mean, that all depends on the actual plant. So it's very difficult or hard to say until I've seen exactly what it is that you want to move. I mean, we can take this, I believe afterwards I can assist you and we can give you a quote and a bit of an estimate on how long we believe it's going to take.
Okay, we can get in touch after this webinar.
Perfect. Thank you very much.
Yeah, we've got another question from Alan. So with that automated conveyor macro, how easily can one implement changes?
So Alan, the automated macro is done to specific standards, obviously, and each person have their own geometry. So what we tend and what we prefer to do is alter our application to suit your specific geometry. And I presume you will have your own standards when it comes to gantry sizes, member sizes, and that sort of thing. So yes, we can quite easily alter our program to conform to your geometry and standards, if that answers your question.
Yes, it does actually, Magnus.
Okay, we've got another question from Mark. What computer specification should one be looking at for the supercomputer that was mentioned? Prioritize CPU over GPU, prioritize CPU over GPU, optimal RAM amount, appreciate discussion. Yeah, look, so you shouldn't need a supercomputer. I've never had a supercomputer and I've done big projects. You should be able to work efficiently without needing I think lots of people throw huge amounts of money at the supercomputer, and to be honest, performance that you gain out of adding that extra hardware over a mid to upper range sort of computer that is sitting in the 50 to 70,000 Rand mark is almost negligible. It's not worth the extra spend. And as far as sort of prioritizing CPU over GPU, that's also, it depends on what different software applications use different things. So when it comes to registration and that type of thing, it's actually more CPU intensive than it is GPU. So a lot of your registration, your point cloud analytics is very much a CPU process. So things you should consider is obviously make sure that the software that you're using can do multi-core threading, which really helps. So that's something that really speeds it up. And then look for a CPU. Make sure your CPU can also do things like is it called multi-core threading, hyper threading, that type. Yeah. And GPU is probably a bit less significant, but when it comes to comes more into play in sort of the BIM side and the modeling side or the rendering side of BIM models. And I think sort of CAD software actually uses something almost different. They would prefer a workstation, which is more like the Xeon process, and that's even a different type of CPU as well. So really, my advice is, you can actually you can spend a lot of money on your office PC, and there's not really significant gains. I know Bonus, he can comment as well. I mean, you look at the size of the projects you do. I mean, what's your take on it?
Yeah, I believe, as Brent said, registering the scan requires a lot of CPU space, and then RAM is very important because you are going to be transferring large amounts of data between components within your computer. So your RAM is important. CPU for registration. You don't really require a strong GPU to process the scans. And then it all depends on your workflow itself. So when we import the scans into Tekla, we tend to break it up into sections so that it's not too demanding on the GPU. So you don't always require to see the entire point cloud within the 3D model and within your 3D workspace. So we simply just take little cuts of the sections that we will be working in, and in Tekla we can switch it on and off as we go.
Yeah, and if you've got, make contact with us, Mark. We can contact after this, and we can look at what we can give you some advice. You can look at what's, are you using scanners now? What scanners have you got? Have you got what other office software do you use? Because you don't really want to always have a dedicated computer for different operations. So we can give you some advice, looking at what you do, what's your workflow.
And I think to add on to that, at ParaMatic in the beginning we started using workstations, and the efficiency you get out of the workstation as opposed to a gaming station or gaming computer is not even relevant. So it was cheaper to buy 2 gaming computers and as opposed to a quadro machine, and it just you don't get the efficiency that you think you ever will. We'll probably save 5 minutes, if even that much. So my opinion, just go for gaming computer.
I agree with that. Okay, next question. Will this webinar be made available for others to download? Yes, everybody that's registered will get a download link for the webinar. Bronwyn's just answered that question as well. Yeah. Okay. So yeah, that looks like that's all the questions that we have in the that have been put in the chat box. So if there isn't any,
yeah, maybe also just to note that all the webinars that we host on OnPoint webinar series will be posted on the Building Point SA website, and I have indicated the link in the chat. So should you want to look at any prior webinars at this stage, there was one prior webinar, but we will be adding subsequent webinars to the website as well. So not only emailed to the registered persons.
Okay, yeah, thanks for that.
Thanks.
Yeah, so if there's any, you want to see this, it can be downloaded also at our website and any other information. And please just, feel free to contact us. Do you have any questions around Scan to BIM? Anything related in the sort of AEC industry, please make contact, and we will try and help where best we can. So thank you very much, everybody. Appreciate the time.
Brent, it's John Carey.
Hi, John.
Can you hear me okay?
Yeah, I can hear you.
Listen, for the purpose of people listening in, I'm General Manager of Building Point. I just wanted to thank you guys. Excellent presentation, Brent, and thank you very much for your contribution, and Marinus. Fantastic, informative. I just want to pick up on one comment. It's one of the first comments in the chat box where someone has asked, can they buy directly from Building Point? Absolutely you can. These kind of solutions, Brent or myself would be very happy to talk to you about. Obviously, take it offline and come and talk to us and come and see you at your offices, your sites. Have a look at the scenarios that you're interested in. So yeah, absolutely, you can come direct to Building Point SA. We particularly specialise in the AEC solutions that Brent was talking about at the beginning. So thank you.
Yeah, sorry, I missed that one. That was the most important question out of the whole lot, and I missed that.
Trust me to spot it.
Apologies for that, Ellen, and thank you very much, John, for picking that up. It's yes, you can definitely buy from us. Thanks. Okay, thanks very much, guys. Appreciate your time, and we'll see you at the next OnPoint webinar. Thanks
everyone.
Cheers.
Cheers.